Hello, my name is Mr. Asprey and this is an EDEXCEL AS paper from 2021. Let's get into it. Got a quadratic inequality. First thing I'm going to do is I'm going to set it equal to 0. And then I'm going to factorize it. I need to find two numbers that add to make -1 and times to make -20. Those are -5 and +4. And then I'm going to solve these brackets to get +5 and -4. It's a quadratic inequality, so I'm just going to draw a quick sketch of what the quadratic would look like. It has it has roots at -4 and at 5. So it's going to look something like this. And we want the part of the quadratic which is greater than 0. So it's this bit here and it's this bit here. So when does that occur? That occurs when x is greater than 5, so to the right of 5, or when x is less than 4, to the left of, -4. So we write it in set theory, because it says here set notation. So we say x has to be less than -4 is a set of numbers, or, in this case we use the union for or, x has to be greater than 5. So we do x colon like this, x is greater than 5. And that's how we do it in set notation. Just quickly added information, if we were looking at less than 0, then we'd be looking at the bit in between -4 and 5, and we would just write that simply as x can be between -4 and 5. So that's what we would do if this question was a less than. Question 2, we've got indices. So what we need to do is make sure that the bases are the same. And all of these are powers of 3. So 9 is 3 squared. So let's just write that as 3 squared. And 3, well, that's already a power of 3. And 81 is 3 to the power 4. Okay, great. Let's look at these brackets here. We can expand those brackets out, and when we do so, the powers multiply. So 2 and x minus 1 need to be multiplied to get 2x minus 2, all over 3y plus 2, and that's equal to 3 to the power 4. Okay, what happens when we divide 3's, like we are doing right here? Well, we subtract the powers. So this becomes 2x minus 2 minus y plus 2. And that's equal to 3 to the 4. So when we divided these 3's right here, we've had to subtract their powers. Okay, so let's simplify that up a bit. That becomes 2x, there's a minus y there, and we have a minus 2 minus another 2, so minus 4. Okay, great. Now we've got two sides of an equation. Both of those have powers of 3, so those powers must be the same. So 2x minus y minus 4 must equal 4. Okay, and what do we actually need here? We need to express y in terms of x. Okay, so let me make y the subject. So what I'm going to do is move y to the other side by adding it to both sides. And then I'm going to subtract 4 to get minus 8. Okay, there we go. So y is equal to 2x minus 8, and we are done. Okay, next question, we've got an integral, and we need to write it so that all of the terms are just a single power of x. So the first term is 3x to the 4 divided by 2x cubed. And splitting up the fraction was going to give me minus 4 over 2x cubed, like this. Okay, so let's look at this first term, and we have x to the 4 divided by x to the 3, which is x to the 1. So this is 3 over 2 x to the 1. And right here, we've got a minus sign, so I could just leave that as a minus. And then 4 over 2 is 2. And the x cubed is on the bottom, so that is the same as having a negative power of x. so x to the minus 3. Okay, right, now we integrate. So we do so by upping the power by 1. So this becomes x to the 2. And then we divide by the new power, which is a 2. And over here, we up the power by 1. Now, minus 3, if I add 1 to it, I get minus 2. So the new power is minus 2. And then we divide by that new power, minus 2. And we always have to add on c. Okay, so what is 3 over 2 divided by 2? Well, that's 3 over 4. What is minus 2? What is minus 2 divided by minus 2? Well, that's just 1, positive 1. So plus positive 1, x to the minus 2 plus c. Like that. Job done. Okay, next question. We have a vectors question. And we have a stone. And it's initially at this point A. And then after 4 seconds, it is at this point B. The motion of the stone is modelled as a particle, yeah, blah, 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 blah. Don't care about that. Okay, prove that the stone passes through the origin. Okay, well, let's first find out what O to A is as a vector. So O to A, if I'm starting at O and I want to get to A, well, I've got to go minus 24 in the I direction. So I'm going to do it as a column. I find it easier as columns. And minus 10 in the J direction. And then what about O to B? Well, O to B is 12 in the I and 5 in the J. That's how I get from the origin 0, 0 to the point B. Okay. And I can see that these are parallel because one is a multiple of the other. So I can say that OA is equal to minus 2 times OB. So if I times OB by minus 2, I get OA. Which means that OA and OB are parallel. And as OA and OB both go through the origin and they're parallel, it means that OAB must be a straight line. Okay, now it's a lot of work for 2 marks, but that does prove that the stone passes through OB, because OA and OB are parallel and they both go through origin. So you get a situation like this where you've got O, you've got A down here, and you've got B up here. And obviously, because the lines are parallel, they're going in the same direction, it means they must both pass through. If I have to go from A to B, I must go through the origin. Okay, calculate the speed of the stone. So let's just say it must be a straight line. The speed of the stone, well, to find the speed, I need to find the distance travelled, and I need to find the time that it's taken. So just, it goes from A and it goes to B and it does it in 4 seconds. Okay, so what is the distance travelled? Well, I've got this nice diagram here which is going to help us out actually. So we've got, this is 24 along and they had to go 10 up. And this was 12 along and 5 up. So in total, I've gone 36 along and 15 up. So that would be how I would get from A to B. And the distance travelled is the magnitude of that, which we find by using Pythagoras' theorem. Because you can see here that this is clearly just like one large right angle triangle. So I need to use my calculator for that. Luckily I've got it right here. So it's root 36 squared plus 15 squared, which gives me 39. Lovely. So therefore the speed is equal to the distance over the time. So it's travelled 39 units and the speed is 4 seconds. Or is it units? It's meters. Yeah, you can clearly see here that it is meters. Okay, so therefore the speed is equal to 39 divided by 4, which is 9.75 meters per second. And I think you might need to put the units there actually, so make sure you do. Yeah, just check the mark scheme and it does require units to get the full marks. Okay, next question, and we have a quadratic, and we have a point P on the quadratic, and it says find the gradient of the tangent at the point P. Okay, so first thing I'm going to do is I am going to differentiate the curve, and that will give me, well, the power is 2, so the 2 comes down and multiplies by the 3 to make 6, and then we drop the power down by 1. And finally, the constant term will differentiate to 0. All constants differentiate to 0. Okay, so that is the gradient function, but I'm interested to find the gradient at the particular point where x equals 2. So that will be 6 times by 2, which is 12. And that will be the gradient of the tangent at that particular point. Lovely. Okay, part B, we have the point Q, and it has an x-coordinate of 2 plus h. We don't know its y-coordinate, and it says find the gradient of the line PQ. Okay, so to find the gradient of a line segment, we need the y and the x of both the 2 points. So I need to find the y value of Q. So the y value of Q I would find by subbing into the line the x value of Q. So this will be, let's do it over here. So the y value of Q will be 3 lots of the x, which is 2 plus h, all squared, and then minus 2. Okay, so this is 3 lots of 4 plus a 2h and another 2h is a 4h plus h squared. So this is going to give me 12 plus 12h plus 3h squared minus 2. So that's 10 plus 12h plus 3h squared. Okay, so that is the y-coordinate of this line. Obviously it's dependent on h because, well, q is dependent on h. Okay, now how do I work out the gradient? Well, it's the change in the y over the change in the x. So how does the y change? Well, we do y2, which is this, minus y1. So let's take away 10 from this, and that's just going to give me 12h plus 3h squared. Okay, and it's over the change in the x, which is x2, which is 2 plus h minus 2. So that will be just h. Okay, both the terms on the top have a factor of h, so I can divide through by h to get 12 plus 3h. Okay, perfect. And then finally it says, explain briefly the relationship between part B and the answer in part A. Well, Q is a point on the curve, and if I were to tend h to 0, then it would mean that Q would get closer and closer to point P. So you reduce the h, which is the gap between point P and point Q in the x, and that's going to move Q closer and closer to P, which means the gradient is going to be getting closer and closer to what it was we calculated in part A. So we can write as h tends to 0, the gradient of PQ equals 12 plus 3 times 0, which is equal to 12, which is the gradient we calculated for P. So the gradient of P calculated in part A. Perfect. Okay, next question, and we have a cubic, and it says using algebra find all the solutions of this equation. Okay, well, it doesn't have a constant term, so it means we can factorize out an x, which gives me x outside, and it gives me a quadratic inside. Okay, so I need to factorize that quadratic. I'm going to use the AC method, made popular by a fantastic teacher called Mr. Packer. What we do is we work out what the AC is, which is 3, because A is the x squared term, B is the x term, and C is the constant term. So we work out AC, and we know that B is minus 17, so we're looking for two numbers that times together to make minus 18, and add together to make minus 17. So those are minus 18 and 1. And then what we do is we just write 3x in both brackets, the numbers that we've just calculated, and we divide it all by 3. Now this one's a straightforward one because one of the brackets divides directly by 3. So in doing so, that's going to give me x minus 6, and the one on the right can stay the same. Okay, great. We have factorized that, so that tells me that my solutions are 0 from the first x being outside the brackets, positive 6 from obviously the second or the first bracket, and then this last one will be minus a third from the final bracket. Okay, now it says, hence find all the real solutions of this monster. Okay, well, I say monster, it's exactly the same as the one at the top, but there's just been a substitution. And that substitution is that x has been replaced with, well, we can see it more clearly if we just focus our eyes on the single x here. It's been replaced with y minus 2 all squared. And that holds true for the other ones, because when you square a square, you're going to get a power 4, and when you cube a square, you're going to get a power 6. Okay, so we can then set all of our solutions that we've calculated equal to y minus 2 all squared. So I can say that 0 was a solution for x, but x is now equal to y minus 2 all squared. I can say 6 was a solution for x, but now it's equal to y minus 2 all squared. And finally, minus a third was a solution, but now x is equal to minus 2 all squared. Okay, let's have a look at this one. We need to square root both sides. And what I do, when I square root 0, that's just going to give me 0. It's not going to give me plus or minus, because you can't have plus or minus 0. So it'll be 0. And then I add 2 to both sides, I get y equals 2. So that's one solution for y. Lovely. The next one, when I do square root 6, I do get plus or minus. And then I add 2 to both sides, so I get 2 plus or minus the square root of 6 is equal to y. So let's just write that as y equals 2 plus or minus root 6. That's a nice way of doing it. And can we square root a negative? Hell no, we can't. So there's no solutions there. So that one can get in the bin. No solutions. Can't square root a negative. So we have our three solutions, 2 and 2 plus or minus root 6. Okay, what have we got here? Question number 7. Parallelogram RPQ PQRS has area 50. Okay, that's useful. PQ has length 14, QR has length 7, and this angle is obtuse. Right, if it's tricky, got to draw a picky. So that's exactly what I'm going to do. I'm going to draw a little parallelogram like that. And then I'm going to say that P must be up here because P is obtuse. And then going round the parallelogram in this order, which is really important, Q, R, S. Okay, PQ has a length 14, so that's 14, and QR has a length 7. It's a parallelogram, so this angle is the same, and this angle is the same. And it says find the size of the angles SPQ. Okay, also because it's a parallelogram, this side is 7 and this side is 14. SPQ. So what I'm going to do, I think I've got it, I know what I'm doing. I'm going to be chopping this in half because I can use my area of a triangle formula. So chop it in half like that, and let's just look at this area, which is going to be 25 centimeters squared for obvious reasons. So a half AB sine C is the area of a triangle, bearing in mind that the A and the B must be they must be either side of the angle, which is capital C. In this case they are, so fantastic. So 25 is equal to 1/2 of A, let's call 14, B 7, and sine of the angle which we're looking for, just going to call it capital C. Okay, so that means that 50 timesing both sides by 2, then dividing by 14 and dividing by 7 is going to equal sine of C, the angle we're looking for. So I need to do sine to the -1 of 50 over 14 times 7. And that's going to give me my answer. So calculator, up you come. In degree mode checking, yes it is. Sine to the -1 of 50 over 14 times 7. And that is equal to 30.2 decimal places, 68. Okay, now that's an acute angle because your calculator will only give you an acute angle when you are doing sine to the -1. So, with that said, you will need to find the obtuse angle, and you can do that by finding the second solution for sine, which is 180 minus. So this gives you 30.68. But then the obtuse angle, which is the angle we're looking for, which is SPQ, is equal to 180 minus that first angle your calculator gives you. So you just need to go to your calculator and do 180 minus the previous answer, and that will give you 149.32, which is the obtuse angle. Okay, so always be careful when doing the sine rule or finding an angle using sine, because there can be two answers, one acute, one obtuse. Okay, now we're asked to find the diagonal SQ, and I'm going to do that using the cosine rule. So SQ squared is equal to 7 squared plus 14 squared minus 2 times 7 times 14 times by cosine of that angle in between them. Okay, so on my calculator I would do 7 squared plus 14 squared minus 2 times 7 times 14 times by cosine of the previous answer, and that is equal to 413. And then I'm going to need to square root that in order to get my value for SQ. So I will square root that previous answer and I will get 20.3. Perfect, and that is in centimetres, and this was in degrees. Job done. Question number 8, here we go, binomial expansion, and we are told that one of the terms, or the x to the power 5 term, is 3402, find the value of a. Okay, so I'm looking just at the fifth term, or the fifth power, sorry, and I will find that by looking at using the formula. So I'll start with the fact that this bracket is expanded to the power 8. So I will do 8 choose, and because I'm looking for the fifth power, that will be 8 choose 5. So that is the Pascal's triangle number. And then we'll need to multiply that by whatever the x term is, which is ax. And I want that to the power 5. And then I'll need to multiply that by whatever the constant term is, or the other term, which in this case is a constant, which is 2, to the power 3. And that is because the powers must add to make the overall power of 8. So 5 and 3 make 8. Okay. Let's now, and this is equal to 3402x to the power 5. Right, so 8 choose. Now the choose button is above the divide sign, so you can't quite see that on the screen. But you do shift and then hit the divide button, and then we're doing that to the power, or not the power, but we're looking for the fifth position, so 5. Okay, and then we can press equals. That's 56. Okay, 56. And then when we do to the power 5 of this here ax, we'd be very careful that we make sure that we raise a to the power 5 as well. Everything inside that bracket needs to be raised to the power 5. And 2 to the 3 is 8. Whoops, shouldn't be an equal sign there. That should be a multiply. And that's 3402x to the 5. Okay, I need to know what 54 times 8 is. That's 448. A to the 5, and we can just cross off these x to the 5s. We don't need those, and they occur on both sides. Okay, and that's equal to 3402. So we just divide through, and then we're going to take the fifth root. And that should do us. So the fifth root of 3402 over 448. So I need to use this button here to do the fifth root of 3402 over 448. And I get 3 over 2. Lovely. That fills me with confidence that I know I've got the answer right. I've got getting such a lovely number like that. Okay, using this value of a, find the constant term in this expansion. Right, tricky questions. I know students don't like these types of questions. We've got to think about where the constant term comes from when we expand this. So this is going to give us lots of terms, loads and loads of terms. And then we're going to multiply each of those by 1. Because 1 is in that bracket there. Okay, so the constant term coming out of the power 8 bracket, well, what is that going to be? Well, the constant term will be 8 choose 0, because the x power I'm going to use will be 0, and the constant term in here is 2, and that's going to be raised to the power 8. Because again, 0 and 8 make 8. Okay. So what will this be? Well, this will just be 8C0 is 1, anything to the power 0 is 1, and 2 to the power 8 is, come on, I know this, 256. Okay, and then that 256 will come out of this bracket and it will be times by 1, so that will definitely be one of our final terms. But there will be another constant term that comes out, and that will be the one when we get an x to the 4 out of this bracket, and then that gets multiplied by this term, because remember, every term in our to the power 8 bracket will need to be multiplied by 1, and it will also need to be multiplied by 1 over x to the 4. So I need to find the term that comes out of that orange bracket which has an x to the 4 power. So that will be using 8 choose 4, because the x term will be to the power 4, and that will mean the 2 will be raised to the power 4 as well, so that 4 and 4 make 8. Okay, I know what a is. It's it's 3 over 2. 8 choose 4, don't know what that is, so let's find what that is. 8 choose 4 is 70. That will be need to multiply by 3 over 2 to the power of 4, because a will be need to be raised to the power of 4. And then that will be need to multiply by 2 to the power of 4. Okay, great. So that is going to give me 5670 times x to the power of 4. And then, like I said, that term will come out of the orange bracket and it'll be multiplied by this term here, and that will then leave us with a constant term. So when that is multiplied through by 1 over x to the power of 4, I will just get 5670. So my overall constant term will be 256 and also 5670 added together to get a total of 5926. Okay, job done. Okay, looks like we're integrating again. This time we have limits. So first things first is I need to write it in a form which I can integrate it. And that is on the denominator. So it's a negative power, and it's also rooted. So that means it's to the power of a half. So it's to the power of negative a half. And that is dx, so we're told it's equal to 20. Okay, so power goes up. So add 1 to the power from minus a half goes to positive a half. And then we need to divide through by the new power, like that. So that's integrated, so now we put it into square brackets. And we have 9 and we have k, and we're told that's equal to 20. Okay, so 6 divided by a half is not 3, it's 12. So it's actually 12x to the power of a half, 9 and k. And 9, I can do this without a calculator actually, which I always encourage you to do if you, I just encourage you to do it. So 9 goes in and it's halved, or sorry, not halved, it's rooted, square rooted to make 3 times by 12 gives me 36. So that's the first term. And then take away the next one. When I sub in k, I'm going to get 12 root k. Okay, lovely. So a little bit of rearranging of this gives me that 12 root k is equal to 36 minus 20, which is 16. So root k is equal to 16 over 12. So root k is equal to 4 over 3. So squaring both sides, I'm going to get 16 over 9. Lovely. Okay, next question we have looks like a proof question, is investigating the following statement about natural numbers. N cubed minus n is a multiple of 4. Okay, you prove using algebra that the statement is true for all odd numbers. Okay, great. So if odd, then that implies that n will equal 2k plus 1, because all odd numbers are an even number, which is like 2 times something, which is even, plus 1 will always give you an odd. So let's check if that statement works. So if I replace that n with a 2k plus 1 and I cube it and then I minus that n, which is 2k plus 1, we'll see what we get. So cubing this will give me 3c0, 2k will need to be cubed, times by 1 to the 0. I'm using the binomial here, by the way, just to speed things up. And then we'll have 3c1, which is 3, and then the 2k will need to be squared, and then 1 will be to the power of 1, because remember the powers must add to make 3 each time, because it's a third, because the power is to 3. 3c2 I know is also 3, and 2k this time will be raised to the power 1, and 1 will be raised to the power 2, and then finally we have 1 is 3 choose 3, and 2k to the power 0, and 1 to the power 3. Okay, maybe not the most efficient way of expanding this triple bracket, but I've started now, so I might as well go on. 2 cubed is 8, so this is 8k cubed. We have 2 squared is 4 times 3 is 12, so 12k squared. We have 2 times 3 here, which is a 6, so that's just 6k. And then here we have, that's 1, that's 1, that's 1, it's all 1. And we're taking away 2k plus 1. Okay, I can see here I've got a plus 1, and I can see I'm taking away a plus 1, so they will cancel. So the last thing to do then is just to collect up. So I've got 8k cubed, I've got plus 12k squared, and I've got 6k minus 2k, which is plus 4k. And I can show this is a multiple of 4 by factorising by 4. So in doing so, this shows that this is a multiple of 4. So right, therefore, multiple of 4. Lovely. Use a counterexample to show the statement is not always true. Okay, well I just need to find a number which works, which doesn't work. And I can already see here that if n equals 2, because 2 cubed minus 2 is 8 minus 2, which is 6, which is not a multiple of 4. Okay, question 11, and we have area of reserve covered by trees. We started on the 1st of January 05, and the area is modelled by this equation, and that t is the number of years after when it started. So it says find the area that was covered by trees just before tree planting started. So that's when t equals 0. So the area is 80 minus 45 e to the 0, which is just 80 minus 45, which is 35. And that's kilometres squared. Okay, great. It then says on January 2019, so that would be when t is equal to 14, because 14 years separate 05 and 19. The area is this. Use this information to find a complete equation for the model giving your value of c. Okay, so we just need to equate the information. So 60 is the area we're told, and that's equal to 80 minus 45 e to the c, which we don't know, but we do know when the area is 60 that t is 14. Great, so a little bit of rearranging gives me 45e to the 14c is equal to 80 minus 60, which is 20. So e to the 14c is equal to 20 over 14. 20 over 45, which is 4 over 9. Okay, so what's the inverse of taking e to the power of something? Well, it's taking ln of both sides. So I'm going to ln both sides like so. And this will completely cancel out and it will bring the 14c down. So I get 14c is equal to ln of 4 over 9. So c is equal to ln of 4 over 9 over 14. It says give your answer for c to 3 significant figures. So I'm going to have to go to the calculator here and type in ln of 4 over 9, and then I need to divide that by 14. Okay, so I get minus 0.0579 to 3 significant figures, and it does, this is where lots of people get caught out, it actually asks you for the equation. So just stating c is not enough. You need to write the equation, which is a equals 80 minus 45 e to the minus 0.0579 t. That is the full equation. That is what's going to get you your final accuracy mark. Okay, the final part says that in 2020 the owners have announced a long-term plan to have 100 kilometers squared, of the nature reserve covered by trees. State a reason why the model is not appropriate. Well, the model's maximum is 80, because we're taking away a function of e, which will always be positive. So we can't get more than 80. So it's not appropriate because 80 is the maximum. 80 is max for model. Done. Okay, question 12. It's asked me to solve this equation and note that the range is up to 450. Okay, we could do that. I'm just going to grab some space here. And we are going to start by doing, we're going to replace that cos squared with a 1 minus sine squared, classic. And that's going to give your equation all in terms of one trig function, which can make it easier to solve. Well, yeah, it's going to make it much easier to solve. So expand out the bracket over there, and then move all of my terms to the right hand side, and that's going to give me a positive sine squared, which is lovely. Okay, can I factorise that? Don't think I can. No, I don't think that can be factorised because minus 25 would be the AC term, so that's no good. So I'm going to have to go to the calculator, and I'm just going to go to equation polynomial degree 2, and it is 5, it is 6, and it was minus 5. Okay, we get minus, or we get plus or minus, we get minus 3 plus or minus root 34 over 5. So I can say that sine theta is equal to minus 3 plus or minus the square root of 34 over 5. Okay, now actually, are they all possible? Well, this one, if I press this, that's between 0 and 1. Good. The next one is not between 0 and 1. Naughty, naughty. So that one was not going to have any solution. So it's only this one that I'm interested in, which is 0.566. Okay. So let's just say that theta is equal to sine to the minus 1 of 0.566. Okay. So what is that going to equal? Well, I need to go over here and I need to do shift sine minus 1 of 0.566, and I get 34.5 to one decimal place. And we know the next solution for sine is always 180 minus. That's going to give me the second solution. And once you've got your two solutions, then you can just add or subtract 360 to either of them as much as you like. So if I add 360 to this one, the second one, that's going to get me over 450. So I don't need to use that one. So I need to add 360 to the first one, and that's going to give me 394.5, which is in the range. So those are the three solutions that we need. Lovely. Okay. Right, let's now look at the next question, which is a student's work, and we've got to see where they've made the mistakes. Okay, so first line looks good, second line looks good, and then they've multiplied through by cos, which is going to be an issue. No, it's not actually, that's fine. It's them dividing by sine, which is the issue. Okay, so here, dividing by sine, x loses a solution of sine x equals 0. And then finally, this part here, they haven't found the second solution. So they have not found the second solution for cos x equals 3 over 5. So those are the two mistakes. And then it says the first four positive solutions in order of size of this equation here are this. Find the value of alpha 4. Okay, well, luckily they've already given us the first solution for when we do inverse cos of 3 over 5, because that will give you this. So that means that 5 alpha plus 40 is equal to 53.1. But we need to find the additional solutions when you do cos to the minus 1. So if I just do it in full, I would do cos to the minus 1 of 3 over 5. I would get this. And then my next solution for cos is always 360 minus. So this is my second solution. And then what I'm going to do is I'm going to add 360 to each of these to get us the next set of solutions. So adding 360 to the one I already have on the calculator is going to give me my fourth solution, which is 666.9. And I also need to add 360 to the one I had the first solution, and that gives me 413.1. Now, It does say that these are the first 4 positive solutions. Now, when I solve for alpha, which I will do by taking away 40 and then dividing by 5, are all of these still going to be positive? Well, yes, they are, because when I take away 40 to this one and divide by 5, it's still positive. So that will definitely be the first positive. This will be the second, this will be the third, this will be the fourth, which is the one I'm looking for. So that's the only one I've been bothered to do, seeing as it's the one I need to find. So I'm going to take away 40, and then I'm going to divide through by 5. And that's going to tell me that alpha 4, the fourth term, is 125.38. So to the nearest degree is 125 degrees. Job done. Question 13 is a bit of a classic using the log graphs. And these questions are so similar, I'm not even going to bother reading the question. I'm just going to do what I always do to solve it, which is start off with the formula they give you, which is this. Take logs of both sides, split up the one over there to get log, using log rules, because these two things here, the p and the m, are multiplied. It means I can write it as the two of them logged added together. So that's log p plus m to the q, and we can bring that down to get q log m. And then finally, I'm going to look at what my variables are. So one of my variables is log h, and the other one is log m. So the log h is obviously on the y-axis, and the log m is on the x-axis. So I'm just going to write this like a y equals mx plus c. So the y is equal to m, which is the gradient, which is what we times by the x. So that's q. And then the variable x is log m, and then plus the intercept, which must be log p. So this is now in the form y equals mx plus c, essentially. Okay, so this is the y, this is the m, this is the x, and this is the c. Okay, so what does it actually ask us for? The value of p. Well, we can find that over here. So log p is equal to the intercept, which I know is 2.25, because it's equal to the c. So this is base 10, so to remove the log in base 10, I have to do 10 to the power of both sides, like so. So I'll need to do 10 to the power of 2.25. So 10 to the power of 2.25, and that is 177 to 3 significant figures, so 178. Okay, great. And then what is the gradient? Well, the gradient, I'm told, is equal to this, and the gradient lines up perfectly with q. So q is the gradient. So I just need to say that q is equal to minus 0.235. And we're done. We've got the value of p and we've got the value of q. Okay. Now it says that we've got a particular mammal that has a mass of 5 kilograms and a resting heart rate of 119 beats per minute. Comment on the suitability of the model for this mammal. Well, let's use the model, shall we, to find out what it would tell us its heart rate would be given its mass. So its heart rate would equal p, which is 178, multiplied by its mass, which we're told is 5, multiplied by q, which is to the minus, not multiplied, to the power of q, which is minus 0.235. Okay, so let's just get that onto the calculator. and that is 178 times 5 to the power of minus 0.2235. That does the job. Okay, so 121.9. Okay, now is that close enough for us to deem acceptable? Well, let's find the error margin, shall we? So let's subtract the actual value to get the difference between the two, and then let's divide that by the actual value to get the percentage error, times it by 100. So that's 2.5 percentage error. So we can say 2.5% error, and that is a good model. Anything under 5% is a good model. So this means it is a good model. Okay. Next it says, with reference to the model, interpret the value of the constant p. The constant p is, well, where did we find the constant p? Let's just go back up. The constant p we found via the intercept. Okay, so this was useful in finding the constant p. And if we look at the model, it'd be quite tempting to say that this would equal the resting heart rate of an animal which has 0 mass, but obviously that wouldn't make any sense. So p is found when log base 10 of m is equal to 0. This point here. And this happens when the mass is equal to 1. So p is the heart rate of a mammal of mass 1 kilogram. And we're done. Question 14, we have a function and it says write f of x in this form where a, b and c are constants to be found. Okay, so that just means complete the square basically. We can do that. So we'll take out a minus 3 from the first two terms, and that would give me minus 4x, because minus 3 times minus 4 is plus 12 as desired. And then what we would do is we would complete the square inside the square bracket. We would take the term here minus 4 and half that to give me x minus 2 all squared, and then we subtract, always subtract, that value minus 2 squared, which is 4. So we're taking away 4. Okay, so a real key skill is to be able to complete the square. And then what we need to do, I got distracted, and that is to multiply through now by minus 3. So multiply out the square bracket. So the minus 3 times by this, and the minus 3 times by the minus 4 to get plus 12 plus 8. So we have minus 3, x minus 2 all squared plus 20. Okay. That is very helpful in finding the coordinates of the maximum point, and the maximum point is when f of x is as big as possible, and this square bracket here can give out only positive values, so the smallest it can give out is 0, and giving us, and as we're taking away that square bracket because it's times by minus 3, we want that square bracket to be 0 to get the smallest possible f of x. So that happens when x equals 2. So m is the point 2, and when that bracket is 0, we get 20 left over. Okay, great. Now it says that what we need to do essentially is to find the area of R. Okay, so what I'm going to do first off is I'm going to split this into a rectangle like so. I'm just going to draw the outline of it nice and clearly. So this rectangle And I'm going to call this area S, the non-shaded region of the rectangle. Okay, so let's first find what R plus S is, so the rectangle that I've just drawn. Well, I know this coordinate is 0, 0, and I know this coordinate is 2, 20. So that distance across is 2, and the distance going up is 20, so the area is 2 times 20, which is 40. Okay, now I can use algebraic integration to find the value of S, because I'm going to integrate under the curve, and I'm going to integrate between the two x values of 0 So I'm going to integrate between 0 and 2, and that's going to give me this region S. Okay, so let's do that. Let's integrate between 0 and 2, and the curve had an equation of, let's just remind ourselves, minus 3x squared plus 12x plus 8. So minus 3x squared plus 12x plus 8 dx. Okay, so when I integrate, I up the power, and then I divide by the new power. I up the power, divide by the new power, and up the power, divide by 1. And that's between 2 and 0. Okay, so let's just simplify this. It's minus x cubed plus 6x squared plus 8x between 2 and 0. I know when I sub in 0, I'm just going to get 0, so I only really need to do the 2 part. Okay, subbing in 2 is going to give me 32. And then again, 0 is going to give you 0, so it's just 32. Okay, so we know S is 32, so we know R is our rectangle, which was 40, minus 32. So it is 8 units squared. Voila! Circles, everyone's worst topic. Let's do it. The equation of a line PN in that form. Okay, well, I know the centre. And I also know this tangent line. And I know, so therefore I can work out the equation of Pn, because it's perpendicular to the tangent line. So that means it will have a gradient. So the gradient of Pn will equal minus 3, because it's the negative reciprocal of a third. So I now also know that it passes through this point, because it obviously goes through the centre. So I can do y minus y1, which is 4, is equal to minus 3x minus x1, which is 7. So this gives me y minus 4 is equal to minus 3x plus 21. So I get y is equal to minus 3x plus 25. Okay, there we go. Now an equation for C. So I know the centre, and I can work out the radius R if I knew what P was, because I know what N is. And I can work out what P is because it's the intersection of two lines which I know the equations of. So let's do that then. Let's set the two equations, y is equal to a third x and y is equal to minus 3x plus 25. Let's solve these simultaneously. And we can do that by setting them equal to each other, because they're both equal to y. If I add 3x to that, I get 10 over 3x. And then that is going to give me x is equal to 75 over 10, which is 7.5. Okay, And the y value, I can just sub back into either of these. I will pick the easiest one, which is just a third of x. So a third of 7.5 is 2.5. So that gives me p. So now what I could do is I can work out the radius by working out the distance between p and n. And the distance formula is the difference in the x's squared plus the difference in the y squared square rooted. So the difference in the x's, well, the x's are 7.5 and 7. So the difference would be, okay, I'll show all my working by doing this. And the difference in the y's would be 2.5 minus 4 all squared. Okay, so let's find the radius then. I have to use my calculator for this. It was the square root of 7.5 minus 7 squared plus 2.5 minus 4 squared. Okay, so I get the square root of 10 over 2. Fine. And in fact, I'll just square that to get what r squared is, because we need that for the equation of the formula. That is 5 over 2. Okay. So the radius was root 10 over 2. And therefore, my equation for C and the equation for a circle is x minus the centre, x coordinate, which is 7.5, squared, plus y minus the, sorry, it wasn't 7.5, it was just 7. Let's just cross that out. Y minus the centre point, which is 4 in the y, squared, and that's equal to the radius squared, and when we square the radius, it gives us 5 over 2. Okay, part B is tricky. It says that we've got another line with the same gradient, and it's also tangent, and it says find the value of k. Okay, so if I have another line which is also tangent, it must look like this, because it has the same gradient as the original line, which I'll just draw in blue here. Okay, so we can also draw a perpendicular like that, and that would go through the centre, and it will have the same gradient as the blue perpendicular, so therefore that line will meet and it will be a perfect diameter. Okay, so on the other side of the circle, we have, let's call it a point Q over here, which is on the other side of the diameter. Okay, so to get to Q, I'm going to do a stepping stone type method. So I'm going to get a different colour, and I'm going to go, well, how do I get from P to the centre? Well, I know the centre is at 7, 4, so I have to take away 0.5, and then I have to go up 1.5. So to get to Q, I've got to do exactly the same thing from the centre. I've got to take away 0.5 from 7, which gives me 6.5. And I've got to add on 1.5 to 4, which gives me 5.5. So those are the coordinates of Q. And we know that because Q and P are on the diameter. And now that I have that, and I know the gradient of the orange line, I can work out the equation of the orange line, because it will be y minus 5.5 is equal to m, which we know is a third, x minus 6.5, like that. Okay, and then what we can do is just expand this out. So I'm going to get a third x, I'm going to get a third times minus 6.5, then add 5.5. So let's do that. So I'll do a 1/3 multiplied by minus 6.5, and then I would add on the 5.5, and I would get 10 over 3. So plus 10 over 3. So that is the k value, 10 over 3. Job done. Okay, final question. And it says that we have all this information. It says show the a value is minus 2.5. Sorry, minus 2. Okay, so let's use the information as given nice and neatly in this kind of bullet point format. This lies on the curve. Well, if that's the case, then I can sub in to 10, and I should, and it should satisfy. So 10 is equal to a times 2 cubed, which is 8, so 8a. 2 squared is 4 times 15 is 60, minus 39 times 2 is 78, plus b. So this means that 8a plus b is equal to 28. Yes, good. Okay, so that's kind of helpful, but we need more information. The gradient of the curve at 210 is minus 3. Right, that could be useful. Let's differentiate the function to get the derivative. And that gives me 3ax squared plus 30x minus 39, and the b cancels. Brilliant. And I know that if I sub in x value of 2, I'm going to get a gradient of minus 3. So minus 3 is equal to 2 squared is 4 times 3 is 12 times a. 2 times 30 is 60, and minus the 39. Okay, so that's plus 21, minus it to that side gives you minus 24 is equal to 12a, so a is equal to minus 2. Okay, like we had to show. Minus 2, perfect. Okay, and now we can use this. Let's just get a bit more space, and we can use this to find. What b is. If a is minus 2, then that's minus 16 plus b equals 28. So b is equal to 44. Okay, part B is asking us to show there is no stationary points. So we can do that by looking at the gradient function. And a stationary point occurs when the gradient equals 0. And the gradient function we have up here, we know a is minus 2, so that's minus 6x squared plus 30x minus 39. So we need to show this has no solutions, so we would do that by looking at its discriminant, so the b squared minus 4ac. So that's 30 squared minus 4 times minus 6 times by minus 39. Okay, so let's just work out what that is. So 30 squared minus 4 times minus 6 times minus 39. That's equal to minus 36, which is negative, which means there are no solutions. Thus, C has no stationary points. Always good just to add the conclusion. Okay, it says write f of x in this form where q is a quadratic expression to be found. So that sounds like I need to do polynomial division, or you could do equating coefficients. I'm just going to divide it because I find it easier. A is minus 2, so that's minus 2x cubed. And then we had 15x squared minus 39x, 15x squared minus 39x, and it was plus b, which is 44. Okay, so how many x's go into minus 2x cubed? That's minus 2x squared. Multiply down by both of these two. I get minus 2x cubed and I get plus 8x squared. I then subtract. This is going to give me 7x squared, and 39x minus 0 is just 39x. Okay, how many x's go into 7x squared? It's 7x. Multiply down. I get 7x squared, and I get 7x times minus 4, which is minus 28x. Subtract minus 39 plus, because there's two minuses there, 28 is going to give me minus 11x. And then bring the 44 down as well. And how many x's go into minus 11x? Well, it's minus 11. Multiply down. Does it work out nice and neatly, give us no remainder? Yes, it does. So I can say that f of x is equal to x minus 4 times by this quadratic here. Lovely. And then it says deduce the coordinates of the points of intersection of the curve with equation this and the coordinate axis. Okay. Well, first off, this has only one solution, and that is at x equals 4. Of course, you could check to see if the quadratic has no solutions, but I know it's not going to have any solutions because the cubic has no turning points. So a cubic with no turning points is just going to go through the axis just once, like this, at x equals 4. Okay, and let's figure out then what the x coordinate will be when it's put through a graph transformation of f of 0.2x. Well, remember that is going to be a stretch in the x-axis, and the scale factor will be 1 over what you multiply by. So this will have a scale factor of 5. So therefore the x coordinate will be 20. So one of the points of coordinate with the axis, one of the points of intersection will be 20, 0. Okay. It will also cross the y-axis. Now, where does the cubic cross the y-axis? Well, it crosses it at the y-intercept, which is plus 44. Now, this is not going to change through this graph transformation, because this only affects the x. It just squishes or stretches in the x. So the other intersection point will be 0, 44. Okay, I hope you enjoyed that, and I hope that was useful. If it was, like and subscribe. See you later.